हे लावशील मॅडम ते माझ्या असताना ते हे झालं ते फ्लोटिंग पडले ते दिवाला दिवा भिजलाय तेव्हा त्याच्या मी माझा भाजला एवढी शिवाय आता त्याची फ्लोटिंग होते तूप जास्त झालं आज जायचं सारखं माझ्या मी जेवायला नाही उशीर होईल जेवून घ्या नाही गुड इव्हनिंग देशपांडे
Good evening. Good evening. Yes, sir.
श्रीवास्तव साहब गुड इव्हनिंग वेंकटेश सचिन जी
Yes, Kishore sir. How are you?
फाइन फाइन
Patel ji, good evening.
Good evening, sir. Good evening. Hi, Mr. Katkar. How are you?
फाइन फाइन
Good.
मैं मेरे को देख रहा है ये थोड़ा सा गड़बड़ हो रहा है
क्यों क्या हो रहा है?
ये अभी शेयर करने में ट्राई इसलिए मैं बोला ना विल स्टार्ट लिटिल अर्ली शेयर में शेयर कंटेंट में मेरा ये पीसी पे क्यों नहीं जा रहा है
नीचे शेयर होगा, शेयर फाइल करके होगा.
नहीं शेयर किया है दैट इज देयर
We can't see your presentation.
No. Normally वो आता है it go to the I have to go to the window ओके आ गया शेयरिंग में गड़बड़ हो रहा है
ये आपका ईमेल आईडी सब दिख रहा है.
हाँ इसलिए अच्छा देन आई कैन ओपन माय प्रेजेंटेशन आल्सो
Yes,
You can.
ओके मैं कर देगा नो प्रॉब्लम दिख रहा है
नहीं, आपको वो ईमेल आईडी वाला ही दिख रहा है. ईमेल ही दिख रहा है सब. हाँ, अभी आ रहा है. नहीं
आ गया
नहीं, अभी तक नहीं आया. आपका वो चेंज करना पड़ेगा.
यस अभी ईमेल में बंद कर देता है
हाँ, आपका ये खोलना पड़ेगा। पीपीटी खोला है आपने सीधा?
हाँ पीपी खोड़ा है।
तो डेस्कटॉप पे रखा है, कहाँ रखा है?
मैं तो इधर भी हूँ। अरे
नहीं, नॉट येट।
मैं तो खोल दिया है, शेयर कर।
No,
No
sir, you have
problem.
stopped your screen sharing. You have to click on share and you will have two options, screen and window. Click on screen.
ओके अभी आ
Yeah,
रहा है।
now it is coming.
Yes.
Yes.
अरे
Yes.
वेरी
Make
गुड, चलो।
make it full, please.
हाँ नहीं वो कर देते, वो कर देते, दैट इज नॉट अ प्रॉब्लम। पर अभी
हाँ,
वो कैसे नहीं हो रहा है।
वो नीचे रहेगा ना, कप रहेगा। हाँ, ऊपर भी है।
हो गया,
हाँ, हो गया।
चलो
करेक्ट।
एटलीस्ट थैंक्स
Yes,
गॉड,
perfect.
थैंक्स गॉड। अरे क्या होता है, यू नो व्हाट हैपेंड मेहुल,
हाँ,
we old people little bit technology थोड़ा सा हमारा कम ही है, so we have to accept it, am I right? I don't know about you but me, I'm not very concerned with this one, थोड़ा सीख लिया वो पता लगा, but not like this one.
करेक्ट करेक्ट
So normally क्या होता है, मेरा सन रहता है, he is expert computer, उसका खुद का कंपनी सब वो करता है, but अभी वो बेंगलोर चला गया।
करेक्ट करेक्ट। इट्स ऑल गेटिंग रिकॉर्डेड। रिकॉर्डिंग इज
हाँ
स्टार्टेड।
नहीं नहीं ओके, नाउ
या
सेकंड स्लाइड दिख रहा है क्या?
यस यस यस।
चलो गुड गुड,
परफेक्ट।
चलो परफेक्ट, थैंक यू वेरी मच
ओके
मेहुल।
ओके, नॉट मी, इट्स मिस्टर वेंकटेश हु हैज हेल्प्ड यू।
ओके
No,
तो अभी
no
क्या,
problem, sir.
या,
Venkatesh is sitting where you are, Venkatesh?
ही इज इन चेन्नई।
Chennai. Okay.
I am from Chennai, sir.
Okay. Yes. So you are supporting us, huh?
Yes, very much, all
Yes.
the time. Yes.
So what is your background, Venkatesh?
I work for KR Industries and we are almost everybody like else. We are into rubber and manufacturing products. Apart from that, we do LSR products and foams and die-cut foams,
Okay. Good.
adhesive rubbers,
Okay.
basically for automotive and EMS.
Okay.
Patelji, by default, I have kept everyone on mute. If but
Yes,
I
correct.
don't have the I don't have the we don't have the facility to mute everyone as and when they unmute. So they have to do it's just
Yes, okay. I
remaining
think
the
I think
participants. Yeah.
participants have been behaving very nicely. They've been keeping themselves on mute most of the time.
Yeah,
So
otherwise,
Yeah.
lot of disturbance will be there, you know.
correct. Yes. I think that should be the way it should be going forward. Yeah.
Thank you. Thank you.
Yeah. Thank you.
But Mehul
Yes,
bhai,
please.
but
Yeah,
I'm telling
बोलिए.
you, okay, मैं सबके सामने तो नहीं बोल सकता है, but the way you have started this, really great, I'm telling you. Means,
I appreciate. Thank
yeah,
you.
really. And not only that, okay, we used to do IRI Mumbai branch, but then you see that it is a limitation. So then you have gone pan India. Now
Yeah.
you guys gone all over the world.
All over the world. Yeah, that's the purpose basically.
Yeah.
Yes, correct. We'll wait for some time.
Yeah, no
14
problem,
people
no
have
problem.
joined so far. So let the numbers swell further.
Yeah. Even initially, when you will start, then I will start. तो थोड़ा 5-10 मिनट तो निकलेगा ऐसे ही, but still
Correct.
not before 8 o'clock will start. 8:05,
Correct.
whatever.
Yes.
You are the boss. You
Sure.
tell me.
Sure. No problem. We'll wait.
But,
Yeah.
and this timing is now very perfect. I'm telling you.
I know. Most of the people have approved of that. So that's the reason.
Because during the day, Saturday, Sunday को मेरे को जाने का इधर ये इसमें working day पे it should be on working day, but in the evening.
Correct. Yes. Correct.
I have got lot of offers during that. Karnataka branch says you also do. Then Dr. Mukhopadhyay say, Katkar, please एक lecture दे दो. But yeah, definitely I don't mind.
Correct.
But yeah, देखो, it's like, whatever we have learned from our mentors, senior mentor, I'll say, mentors तो अभी भी है, and we have to give it back to the industry. Right?
That is exactly the purpose, actually.
Yeah,
We should be able to
yeah.
share some knowledge and
And not
leave.
only that,
I see what is
another-
happening now. Purpose of starting this group was that the Europe and USA people are look at all the developed countries rather are looking at India now. So our small scale industry has some difficulty in exposure to good technical knowledge and solving their problems. So I thought that this kind of group would help and provide platform to people to solve their problems. And I'm glad that last almost 2 months now people have been asking and interacting. So
Right.
that's very positive.
hey, Mehul, I'll go one step ahead.
हाँ.
It is not only non-tire. अभी टायर में क्या है? Suppose you are in mixing only. You don't have any knowledge others. If someone
Correct.
want interest, vulcanization, accelerators, antioxidant, lot of things we can build, which is required if you want to go up. Otherwise, you will remain in mixing only.
Yeah, but tire industry has the training programs and all these things, which non-tire cannot afford to do that.
Yeah. That is
So-
why we have IRI has a major role to play. I always
know.
highlight.
True,
And I
true.
think we should compliment Mehul Boy. He
हाँ.
was the one who really, he had a vision.
Yeah.
Started during COVID time, these kind of
Yeah.
webinars.
Yes.
That
Okay.
is true.
That time also,
Yeah.
I took 2 lectures, huh? Mehul bhai? 2-3
Yeah,
lectures I have taken.
correct, correct.
So hats off to him. You had a vision, Mehul Boy.
Oh, thank you very much. I know, yeah, it's ultimately like Mr. Katkar said, we give back to the industry. That's the purpose. Good.
Another 10
It is
years.
8 o'clock already, but I think the number is 32 so far. So we wait for another 3-4 minutes before we
Okay.
start. Yeah.
Mehul Boy, we missed you at Baroda.
Are you surprised?
Huh?
Are you surprised? I'm saying.
No, at least I should acknowledge that, no?
I don't know. That is true. We'll talk sometime about that. Yeah, no
Okay,
problem.
right, man. Thank you.
Okay.
Am I audible properly, na? Mehul bhai?
Yes, sir. Yes, sir. Very much. Perfect.
Perfect. Mehul Boy, shall we start?
Yeah, it's number is 46 so far. So I was expecting 50 cross करेंगे. We will start.
चलो
ठीक है,
एक
ठीक है.
और 5 मिनट रुकते हैं. ठीक है.
और
ठीक है.
2-3 मिनट रुकेंगे. I am very particular otherwise to start on time. So I'm just waiting for people to join in, that's all. I think let's we have just touched 50. So people will join in. If you don't mind, Mr. Katkar, we can start the evening's program. Yeah,
Yes.
okay. Yeah, good evening, everybody. This is Mehul Patel here again. One more webinar for all of you. Today's topic is very, very important. As you know, curing system and the kind of curing system you employ in your formula plays a major role, particularly when it comes to the new regulations of nitrosamine free and ROHS compliant and order free and test free and FDA approved and all these kind of systems, right? So we have today evening we have one of the very highly rated veteran person who is going to be talking about this curing systems, Mr. Kishore Katkar. He's been my friend for last almost 35-40 years now, and he himself has been in the industry for more than 45 years. So he's currently, as you know, he's currently the Director of Marketing and Technical Service of Finorchem Limited. With this short introduction, I will request Mr. Katkar to take over. Thank you. Sorry, before that, I will request, I mean, like I do every time, I will request everybody to keep yourself muted and ask the questions in the chat box. So all the questions will be answered after the presentation is over. Here, Mr. Katkar, you may take over, please.
Thank you, Mehul. I think thanks Mehul and Mehul team. This is initiative of webinar. I think we started in during the Corona, which was the requirement of that day. And it was very successful. And then it was replicated all India basis. And now I think another way, Mehul Bhai have started this. So this is that. Though the subject is very simple, but I thought that better to review again. Start with that, and a lot of to come follow for other wherever I get opportunity. Before that, maybe I will take 2-3 slides regarding company, because Finorchem is a new name. People maybe a youngster maybe not knowing. I'll take only 2-3, and then I will start the subject without taking any brand name and all this. Don't worry. So Finorchem journey is very important. Original company is Acmechem, which is 1994 small company, started with the peptizer, and then they added processing aid, then they are added the specialty antioxidants, etc. And into the major change happened in 2019 when Merchem, which was one of the good company of rubber chemicals, and it was closed because of a known reason. And Acmechem Group acquired this Merchem, and with the capacity expansion in 2020, they started this Merchem plant in Panoli, and with a total production capacity of 50,000. I'm telling you, it was the need of the Indian rubber industry because there was a vacuum. So industry requested our MD, Mr. Vulani, to take the interest, and he grabbed, and in order to help the industry, Merchem and Merchem was taken over by Acmechem. But with the two company, both are in the Gujarat, in Panoli JDIC. So we decided to merge both the company, and we recrystallized this as a new company's name as Finorchem in 2022. After that, we have done a lot of investment and the new green project. In 2023, we started a technology innovation center, which comprised of R&D center, then the rubber testing laboratory, then the pilot plants. Then in 2024, we started a greenfield producer resin plant with 5 independent lines with 3,000 capacity. And in 2025, we went for the backward integration of 6-PPD. The major raw material is 4-ADPA, so that the over dependency on the Europe and China we want to reduce. So this was the journey, and this journey will continue. Just to go very fast. So we have these all standards antioxidants of 6-PPD TMQ. In addition to that, we have 100 that is DPDBD. Many big companies have stopped this production, but we continue and we are running full production. And then additional BL50, these are acetone condensate. And we have some non-steady antioxidant of MBI series as well as CPL and 445. Peptizer, again, I told you, we used to have a PCD base, which we have stopped. Now we have environmentally friendly DBD based peptizer. Then all standard accelerators like MBT, CBS, sulfonamides. The green I have mentioned deliberately, these are the new product where I will just touch. The TBSI, this is the sulfonamide, new sulfonamide, which will be replacing DCBS because DCBS is on the borderline of nitrosamine. In Japan, it is a restriction for the volume, so will not go. Then DN, this is one pack accelerator mix for EPDM. Then a lot of processing gate. Again, you will see the two green, Acmetol JV46F and Acmetol 2000 S2000. These are basically for the silica, good dispersion. Then silica coupling agent like phenocil 69, SI69 equivalent. Then carbon black coupling agent like Marnox, MMH, and IDH. These are all equivalent of Otsuka product. Because carbon black is now for the car tire, you can use the silent and the silica. But for the bigger tire, there is no option. You have to use carbon black and how to improve the rolling resistance. So reduce the rolling resistance and the traction, etc. Anti-reversion agent, there are a lot of anti-reversions are getting imported. So we thought that we'll develop. So we have phenolic BDZTH equivalent to Vulcanization, phenolic 900 equivalent to Percolink. So these are the anti-reversion, and there are also a few in pipeline equivalent to HTS and bisphylide. Then others are we have sulfur donors and we have TPS, that is thiophosphate. Then I told you in 2024 we started the resin plant. We have all type of resins, tachypire, super tachypire. Then heat reactive resins, I will not go in. Maybe another special lecture we will take. Cut and chip resistance it is an Indian product, CCR 120. These are improvement for the conveyor belts which are used in the minings. Then die bonding agent, as you know, we have HMT, HMM 65, and also we have bonding resins. These are resorcinol, that is methanol acceptor, and HMM is a methanol donor. 10 enantiomer. Then we have multi-purpose terpene phenolic resin and phenolic adhesive resins for the adhesive industry. So with this is the overall we'll not go in details about the product, but we are the widest range of rubber chemicals, specialty rubber chemicals, anti-reversion agents, and the resin. So with that, I'm going to our topics of today. So my flow will be vulcanization in brief, sulfur accelerators, other crosslink systems, retarders, and nitrosamine issue. What is a vulcanization? A process in which rubber, through a change in its chemical structure, that is crosslinking, is converted to a condition in which the elastic properties are confirmed, because rubber itself is elastic, or re-established, or improved, or extended over a greater range of temperature. In some cases, the process is carried to a point where the substance will become rigid, that is ebonite. Properties of vulcanite, there are two types of. One depends on the network structure, which is we have basically for the vulcanized systems, and the curing systems are participate. Depends on network structure, the elasticity of rubber vulcanization, resilience, wear and tear properties, tensile strength, tear strength, abrasion resistance, modulus hardness. So these are all depends on the network structure, that is vulcanization, the crosslink system. Aging properties are to some extent, you will surprise, because we always talk whenever aging comes, you are concerned with the antioxidant you can improve, but no. Even the network structure also contributing to the aging property to some extent. There are some property which are not dependent on the network structures, mainly on the polymer, that is low temperature flexibility, gas permeability, chemical structure, that is unsaturation, and electrical insulation resistance. So when we talk about vulcanization, we obviously you talk about the standard curves modulus against the cure time, which is divided into 5 part A, B, C, D, E. What is one? What is A? This is the incubation time, heating time, scotch time, vulcanization time. T is the plateau and the reversion. We'll go a little bit on that, which is very important. Incubation period, that is a warming up period. Rubber compounds getting heated to curing temperature due to the thermoplasticity of uncured rubber. Modulus come down. This is a physical process. There is no chemical process. Rate of warming up depends upon the temperature difference between the heating medium and the rubber compound, thermal conductivity of rubber compounds, and configuration of the rubber part. Rubber compound is a very bad conductor of heat, and in case of thick article, the warming up period can be very long. Maybe you have to do separate warming of thick articles either by electrical heating or hot air salts in order to give the lower vulcanization time. Induction period is nothing but the scotch time or mold flow time. Time interval at the curing temperature during which no measurable crosslinks can be observed. This period depends upon the polymer curating system and the heat history. Induction period is safety margin in processing of the stock. Induction of storage life of the stock. Induction period must be adequate for the processing involved, continuously getting reduced during processing or storage at high temperature. So again, depend upon the whether it is a simple molding or it is when you are building the product. This cost safety is very important for that type of product when your product is building, whether it is a hose, whether it is a tire, whether it is a conveyor belt. Too long curing time in hot air or in open steam curing, it is disadvantage. So where you require a very short curing time. If it is long, then you will find in hot air cure, sagging and de-shaping of the product. Too short, scorching during processing, improper fusion of components, flow cracks, and bad heating during the molding. These are all important to reduce the rejection. Because if you're too short, you will find your proper product will be not there. There are a lot of cracks will be there. Flow will be not there. These are all there. Because I am telling you for the non-tire industry, this is very, very important. Because we do a lot of good formulation. We use polymers. We use good raw materials. But we don't give our importance to the processing as well as the proper vulcanization system. Vulcanization time. The major part of the cure time should be short to achieve the faster production cycle. Again, depends upon the product. The plateau. This is a very important part. The time period curing temperature during which the physical property remain constant at the maximum value. Why it is important? Because long plateau essentials in under practical condition, means during the production at the factory level, particularly in the non-tire, overcure cannot be avoided. When your overcure is there, you will find the curing will be not uniform, the properties will be not uniform, and then your performance will be not uniform. Curing of thick articles. Temperature at the center may not be even attained. When you have thick articles like dock fender, solid tire, rollers, engine mounting, pre-cured retake. When you are curing this, what will observe? When the curing of thick article, temperature at the center may not even attain the cure temperature by the time external surface is cured. And by the time the vulcanization is complete at the center, the external surface is overcured. So this is a very practical problem. So how to do that? This is very important because once your vulcanization system is better, giving the good plateau, some variation in the vulcanization time will take care of the uniform physical property even for the thick article. There's also V belts and conveyor belt. This is also very thick and long rubber article. They are normally produced discontinuously, overlap joints, and joints are getting a double cure. Normally now people are using roto cure, etc., where continuous curing is done. Reversion. Now, in spite of that, what we observed only in case of natural rubber, polyisoprene, butyl, wherever double bond has more, you will find, and with a normal sulfur cure, their reversion is there. What is a reversion? Physical property like tensile, tear strength, modulus, and hardness drop. Elongation and breaks increases because elongation is reversible to the modulus. Surface may become tacky because if your hardness is going down, modulus is going down, surface will become tacky and your resistance to aging goes down. Degradation is physical property due to the part loss of cross-linkage during the breakdown of a polysaccharide cross-linkage. You can see here the vulcanized curve modulus aggregate cure. In case of natural, once you get the optimum cure, if you continue the vulcanization, you will get the reversion. Your modulus is coming down. Obviously, the performance will come down. In the reverse case, in case of synthetic rubber like SBR, polychlorine nitrile, where patent system, what you observe is the Morchik modulus. What is the Morchik modulus? You will continuously, modulus will go up. Even after vulcanization, even during the service, modulus is going. But that is also not acceptable. Suppose you want to maintain the hardness for any, like pre-cured trade or trade in the car tire. You want to maintain hardness of 64, 65. But because of ACR, this modulus will go up and you will find your physical property also come. That is also not there. But okay, we will discuss that. So what is happening in reversion? So that you have to understand. So now you will see here, normally during the vulcanization, what you observed, you get a monosulfide, that is one sulfur, disulfide, you have polysulfide, at least more than 3 sulfur atoms, and sometimes a pendant group of sulfur. So during the reversion process, mean the ore cure, there will be a breakage of chain that you can see from first. Rearrangement of cyclization often happens. So the chain itself will give cyclization, there is no cross-linking. Shortage of cross-linking, polysulfide linkage, which at high temperature and reversion will be substantial more, and you will find polysulfide will give the di or monosulfide. And then there is also conjugated double bond will be there in the main chain. So in nutshell, what you observed is that total cross-link density will come down. Means your modulus will come down during the reversion. And once the modulus and tensile come down, your performance of the product will come down. So during the today's lecture, we will see that with the sulfur and accelerators, how you can maintain or optimize the, should avoid the reversion. And obviously there is a new crosslink also is happening wherever there is a pendant group of sulfur. Now sulfur cure. With a normal sulfur, when you are using 2 to 6 part, what you observed? You observed monosulfide, disulfide, and polysulfide. Mono and disulfide linkage are thermally stable, and polysulfide linkage are unstable. Why? Because you can see in dissociate energy, in carbon-carbon, which is normally happen in the peroxide cure, the dissociate energy is highest at 335 kilojoule per mole. And when you go for mono, it is 310, di it is 280. But when you have polysulfide, you can see 142. So when the sulfur is more than 4, the dissociative energy required to break the CC bond is much lower. That is why whenever there is a reversion is there, you will observe that polysulfide linkage will break to the monosulfide or di. So now, why this mono, di, and polysulfide? What are the advantage and what are the disadvantage? Because for some particles, wherever flexibly required, where are good, we'll see that. So polysulfide linkage, what are the advantage? Gives better tensile strength, better tear properties, and in natural rubber, it gives a flex and fatigue resistance. So there are some products where these property predominantly required to get the highest performance, like pre-cured trend. You have injure bounding is there. The side wall is there. Conveyor belt is there. These are very important. We'll see that. What are the disadvantage? On prolonged cure, reversion in natural rubber, what we have seen in the previous slide. Unstable at higher temperature. Breaks and reforms, that also we have seen. Higher composite at higher temperature, because once your polysulfide linkage are broken, monosulfide dipeptide, composite at higher temperature will be lower, and higher rate of oxidation during high temperature surface. That I said, even aging property also will get affected. Though you have partially compensated by using antioxidant all this, but if you have overcure is there, that I'll show in the next few slides how even aging properties get affected of this. Normal sulfur system, which is normally around 1.5 pHr, but you have seen the advantage in natural good wear and tear property, good flex property, disadvantage, reversion, poor aging characteristic at high temperature, poor compression set, resistant high temperature is less. Now, what are the options? Reduction in sulfur level with increase in accelerator dosage to reduce the proportion of unstable polysulfide crosslinking and increase that of the stable mono and dispalate. As you increase, as you reduce the sulfur, obviously proportional, you have to increase the accelerator, because the molar proportion, the product of sulfur and accelerator should be remain constant. That is very important to get the desired cross-linking. So in case of normal sulfur, it goes from 1.2 to 3 pHr, even go up to the 4 pHr. In semi means is a compromise between normal sulfur and EV system around 0.8 to 1.5, and Tyram cure is basically a sulfur donor system around 0 to 0.3 of sulfur, and where you use sulfur donor as 2.5 to 3.5 pHr. We will touch this all little bit on the next slide. Now you can see here the modulus and with a normal sulfur, semi-EV and the EV. You can see as your cure time increases, your normal sulfur, there is a reversion will be there, modulus will come down. EV is give you a slightly plateau, your modulus is maintained, and semi-EV is compromised between the normal sulfur and EV system. Now you can see that the same product, if you do the aging, tensile retention versus the aging period at 100 degrees centigrade by days. Normal sulfur, even during the aging also, the tensile retention is much, much lower. EV is better than normal sulfur and semi-EV, but Tyram, that is the sulfur donor systems, gives even the better aging properties at 100 degrees centigrade. So what is the sulfur donor? Chemicals which during the cure release the sulfur to give only mono and disulfide crosslinking. What are the sulfur donor? TMTD. It acts as a secondary accelerator as well as sulfur donor. TBZTD. This is a nitrosamine free accelerators, secondary accelerator as well as sulfur donor. And DTDM, dithiodiamorpholine, is again is only sulfur donor, not accelerators. So TDM, Tyram, that is TMTD, it acts as a dual character as secondary accelerator as well as the sulfur donor. Now optimum cure. Now rheometer gives changes in shear modulus with cure time. You can see in the graph T90 and 100. So how to come to conclusion optimum cure? It's very simple. People say go by rheometer to find out T100. No. Now you can understand what I'm talking about. Rheometer gives changes in shear modulus with cure time. Optimum time is taken at T90 because the properties like tensile strength, shear strength are about their maximum at this stage of cure. Because we normally talk about tensile strength and shear strength. However, not all the properties of the rubber vulcanizer are at their optimum at this stage of cure. Tensile and shears are there, but their property you can see in the next few slide, which properties are not optimum at T90. Okay. So then what you have to do? In other properties are important, then these properties may attain their optimum value at different stage of cure, which is very important. Optimum time is to be taken as the cure time at which the most important property desired in the final products are at their optimum balance. Now you can see here. Now optimum cure for different property. Tensile. Tensile is normally, as I said, tensile and tear, you get T90. Afterwards, there will be a drop in the tensile. If your further curing will be there, that is called as reversion. Hardness you can see still on the slightly on higher side. Modulus you can see, and elongation. These are with natural rubber trade compound. Now you can see other properties. Compression set. Even if you increase the temperature for compensate, you required higher crosslink density. So obviously the cure time required for particular application will be higher. So you can see the modulus, you can see the resilience. So in short, we will not go in detail. For each property, there is a different timing of optimum cutting. So your optimum cure will be, you will take which property you are looking for and which property is important for the final product for their performance. Obviously, you have to add the minutes of cure time depends upon the thickness of the part. That is additional. Okay. Now here you can see I have mentioned about even aging property is important. Now in this case, tensile, it is cure at different timing, 30 minutes, 60 minutes, 90 minutes, and 120. What you observe? 30 minutes gives the higher tensile cell original also, and 120 is gives the lower. And when you age this product, you will find there is a drop in the tensile strength. Higher the temperature during the cure, higher the time during the optimum cure, you will find there is a drop in the tensile also. So these are also important for that. Now, vulcanization comes with a different degree of stiffness. So you can see the first case, you can see here, this is the vulcanization system with a shorter reaction time. You can see you go here and then it is going like this. Then you have the vulcanization system with a longer cure reaction time. It goes and like this, like this, like this. So it is a long reaction time. Then vulcanization system with a marching modulus. You can see, this is the vulcanization modulus and this is your vulcanization system with a long reaction time. So in case of marching modulus, you can see it is not optimum the modulus yet. It is goes on increasing. And then ideals will be rectangle curves. You get a very good scotch safety, you get a faster cure, and then plateau. So ultimately, the rubber technologies are doctor of the rubber technology. He want to be optimized. The curing system should be like this. Yes, it is possible to do that by using the mixture of accelerators, proper accelerators, and sulfur ratio that we'll see. Practical vulcanization. Temperature, depending on the type of product, polymer and curative system, equipment and process what you are using for the vulcanization. Now you have heard about the cold cure or room temperature cure, which is around 22 to 40 degree. Normally repairing of the patch, these are curing at room temperature. Hot air, 70 to 140. So you can't go more than that. Steam cure, 100 and 260 degree. And there are special cure like liquid curing medium, ultra high frequency, injection molding, electric heating, where your temperature can go up to 240 degrees centigrade. Now, first, what are the requirements? External pressure. When it is required? Why it is required? External pressure, that is unvulcanized rubber, may contain traces of moisture from rubber compounds, ingredients, dissolved gases, traces of solvent. If solvent is used during the processing, many people use in the hoses or during the bonding process, something like that. Sometimes moisture generate during vulcanization. Even sometimes moisture is coming from the compound also. Moisture generated during vulcanization reaction of zinc oxide and stearic acid, and zinc oxide and thiol groups gives the moisture reaction, and moisture will become into the rubber compound. And this moisture, if it remain into that, and if you don't give the pressure during the vulcanization, you will find there will be a bubbles into the rubber vulcanizing. In case of pure temperature below 100 degree, or in case of very thin rubber film, like the rubber threads or the glues, no external, or the fabric, no external pressure generally necessary. In the hot air cure, on the latex cure, there is no pressure. For cure temperature above 100 degree, external pressure slightly more than the saturated steam pressure and the curing temperature necessary. I given you example. Suppose your curing temperature 142, which is equivalent to saturated steam of 3 atmosphere. So above that 1 degree means external pressure should be 45 atmosphere to keep the mold closed and give the pressure during the vulcanization, so that there will be no faults in the rubber vulcanizing. Now, after this vulcanizing system, we will go for the what type of accelerators and the others curing system will be there. Because I think someone will ask who is not from the rubber industry, so many accelerators are there. If the accelerator is required, why not only few accelerators? It will be very comfortable job for rubber technologists. But no, there are so many accelerators. We will go a little bit detail in that. Why so many accelerators are required? What are the functions and what the rubber technologists or doctors can utilize these accelerators and get the better optimum cures, faster cures, and the no reversion, etc. Now, curing system. What is the curing system? Selection of curing system is based on the base polymer. Natural rubber is there, nitrile is there, whether it is a double bond is there, whether it is a saturated rug, EPM, a lot of things are there. That is a base polymer. Whether a double bond in the main chain or side chain is there or not, whether I can use sulfur accelerator system depends on the base polymer. Processing condition. What type of process, whether it is a hot air cure, whether it is a liquid cure, whether it is HEF cure, whether it is a continuous cure like hoses, etc. Curing condition also. Then service requirement of the rubber product. That is also very. These four conditions are very important. Now curing system. Now we have seen that depends upon the base polymer, properties, etc. What type of curing systems are there? The most important, almost 85% of polymers use sulfur or sulfur bearing material because tire is almost 70% and tire using sulfur and sulfur bearing and non-tire. That is why 85% is sulfur and sulfur. It is very comfortable, very economical, where we can use natural rubber, isoprene, synthetic natural rubber, SBR, butyl, PBR, EPDM, nitrile, XNBR, that is carboxylated nitrile, and HNBR, hydrogen nitrile. All these rubber have the double bond either in the main chain or in the side chain, which is required for sulfur accelerator crosslinking. Okay. Organic peroxide. This is very important. So now what you will do when there is no double bond like EPM, silicon. So these polymers where there is no double bond or saturated polymers, they don't have any option. You have to use organic peroxide. But even for some polymers where you require a special properties and good compression side, you want cleaner vulcanized, you want lighter color, etc. You don't want get contamination. So even for some polymers like NBR, PVC, HNBR, those even can be cross-linked by sulfur accelerator peroxide here. So EPM, it is again saturated rubber, EPDM, silicon, urethane, chlorinated polyethylene, cross-linked polyethylene, VAMAC, PVC NBR, NBR, HMBR. These polymers can be cross-linked with peroxide. Obviously, saturated rubber has to be cross-linked with peroxide. Metal oxide, like zinc oxide and magnesium oxide, lead oxide, polychloropene, chlorosulfate polyethylene, polysulfide, CIR and BIR. These are chloro, butyl and bromobutyl. Organic amine, these are special polymers, acrylic, fluorocarbon, epichlorohydrin, VAMAC, and phenolic resin is butyl. I will touch few. I'm not going to do this because for each thing, I think you require one lecture. Curative system. A good curative system should give adequate scotch safety, fast rate of vulcanization, long plateau, and vulcanization with a good physical property and good aging property. Obviously, once you get this, better performance. Curative systems decided by curing characteristics, design in the manufacturing process, and the functional requirement of the vulcanizers. This is very important. So you required depends upon the polymer, the manufacturing process, and very important, the functional requirement of the vulcanizer, whatever the product you are manufacturing. Different curing characters desired in compounds designed for hot air cure. What is normally for hot cure? Very far onset, because otherwise sagging and stickiness will happen because surface will get oxidized with that. Because in hot air, there is oxygen is there. So very fast onset of vulcanization, fast rate of cure at lower temperature. As we have seen that at around 100 degree in a hot air cures, your balloons or you have a text fabric or glows, latex, these are cured at a lower temperature. Open steam cure, fast onset of vulcanization. Again, there is a possibility of oxidation and sagging and spot of the steam cure. So fast onset of vulcanization is required to get a proper shape. Compression molding, adequate mold flow time. It has to be mold, will not go detail. Injection molding, adequate mold flow time, because injection molding done at a higher temperature for productivity. So you required the mold should be completely full. So adequate mold flow time and good reversion resistance. Because many times, whenever you are injection molding, the material is remain into the sludge. So that should not be overcure and there should not be reversion resistance. Vulcanization of thick article, excellent reversion resistance. So I think this reversion resistance we will discuss maybe next time. I will touch this lecture will be only confined to the sulfur and accelerators, not anti-reversion. A wide range of accelerators are necessary to fulfill this requirement, and a wide number of accelerators are available. Now you can understand why so many accelerators are there and why many times you have to use the combination of 2-3 accelerators will come out. Accelerators, a chemical which increase the rate of vulcanization of rubber compounds with a crosslinking agent like sulfur. Now you understand who was the creator? The Goodyear was the creator for vulcanization. So he used first the heat, and by that the rubber has vulcanized or cured. But the process was very slow. So in order to increase the cure, the accelerator was invented, and different accelerators are there. What are the advantage of use? It is not only the rate of cure, but there are many advantages are there. First, increase output, reduce variability of cure. By using a proper accelerator sulfur or the combination accelerator, you can get a consistent cure rate. Better physical properties, consistent physical properties, better aging properties, and better color of vulcanizing. Why I'm taking? When you cure at higher temperature, this is more applicable to the non-black product, white or color product. If you cured at higher temperature, you will find the color will be darker shade or blackish shade. So suppose you want to have a good color, you have to cure at lower temperature. Then according to you have to use the accelerators. Besides this, there are FDA accelerators. I think Mehul Patel was talking about nitrosamine free, FDA approved, then SVSC, a lot of things are there. We will not go into it, but these are the basic advantage of use of accelerators along with the sulfur vulcanization. What are the curative system? Curative system, the type and amount of accelerators and the amount of sulfur in case of GP rubber, that is general purpose life. What are the general purpose? Natural rubber, SBR, polybutadiene, these are the general purpose rubber. Why they call general purpose rubber? Rubbers which are mainly used by the tire and allied industry, they call as GP rubber. And obviously the other rubber also can be crosslinked. I told you, NBR, IR, EPDM, XNBR, HNBR, because they have the double bond either in the main chain or in the side chain, which can be used for the crosslink with sulfur and accelerator. The crosslink agent influence the curing characteristics of the rubber compound. What type of they influence? We have seen the 5 system. Remember, incubation, curing system is not participating or not contributing to the incubation heating system. It contributes after that. That is the induction time or Scotch safety, rate of vulcanization, plateau, and reversion. Major quantity of polymers usage. I have told you, general purpose polymers are cured with sulfur as crosslink agent. NR, SBR, VIR, EPDM, etc., XNBR, HNBR, that. NBR, PVC. Special purpose polymer like NBR also we are talking about. These rubbers can be cross-linked with sulfur accelerator. First, if you see, sulfur accelerator is economical curing system and used mainly by the all tire industry. That is why I told you 85% of rubbers are cross-linked by sulfur accelerator system. Accelerator for sulfur vulcanization, there is an old classification people used to this on their activity in natural rubber based compound. Slow accelerator, normally cure temperature 120 and 40, medium fast accelerator, ultra accelerator, and super ultra accelerator for room temperature. But now the classification has been changed, which is more relevant. Azole and sulfonamide class, tyrone class, and diacarbonate class, these are all acidic accelerators. And there is a basic accelerators that is gonidine, that is DPG, DOTG, and amine class, HMT, HMMM. There are a lot of others we will discuss after. And there is a synergy between acidic and basic accelerators. I think synergy means when you use one accelerator, suppose you are using 2 PHR, and when you use 1 PHR of one accelerator and 1 PHR of acidic accelerator, 1 PHR of basic accelerator, the curing system with the synergy system will give the more better curing system or faster cure compared to individual. That is called synergy. Synergy is there in the accelerator when you use acid accelerator and basic accelerator. Synergy is also there in the antioxidant, just for the information. Now you can see, even those person who don't understand the whole rubber technology, you can see a different type of accelerators. I have taken a few. I have taken from the thiazole class, MBT, MBTS. I have taken CBS, which is the sulfonamide. I have taken the ZDC, which is thiocarbamate, and there is a DPG, is the diaphanic guanidine. Now we can see that DPG is giving a slow cure, longer cure time, not giving that type of modulus. So for the engine mounting, for the longer cure, thick article you can use. MBTMS is a general accelerator, and CBH which gives the better scope safety, good plateaus, and good physical quality. ZDC, very picky cure, very scotch time, very fast cure. So it is not normally used in the general purpose rubber. So this is a just. You can see the even sulfonamide also. Why so many sulfonamides are used? CBS, TBBS, MBS, DCBS. You can see that CBS gives better scotch safety, faster cure, and not. So for the product like in the molded product or in the non-tire industry, for hoses, for pre-cured trade, for small tires, you can use CBS very well. You can get a better scotch safety and good physical property. But when you are going to thicker articles like pre-cured tread or bigger tires, like passengers car tires, or you can say truck tires or conveyor belts, you can use TBBS type of things, which is given higher scotch safety. And there was also in MBS was there, which has a very good scotch safety, and which was predominantly used by the tire industry for the truck tire and a bigger tire earlier, but mainly for bias tires, because MBS is having a problem of nitrosamine that is carcinogenic. Slowly, people has gone away. They have discontinued use of MBS. Even tire industry has stopped, but non-tire industry also slowly going away from, and because it can be replaced by CBS or TBBS easily. Obviously, it is not one-to-one. You have to adjust some dosage, some retarder or combination of that. Anyone can help you in that case. Then DCBS. DCBS, though it is hard, this is having a very high scotch safety. You can see here, this is a DCBS, very scotch safety, but it is a slightly slow curing. So it is not used for the normal vulcanization for product, but product where the bonding is required in the case of nylon, polyester, or mainly for steel cord, where the high scotch safety is required, because bonding should take place before the vulcanization start. So you can understand, even in the sulfur, there is one more is TBS. So you can see that by using even different accelerators, sulfonamide accelerators, you can manage your vulcanization system the way you want. You can control the scotch safety, you can control the cure rate and the plateau, etc. I will not go in much detail on that because these are general accelerators. First, MBT, MBTS, these are thiazole, mainly used by the general purpose rubber, by the accelerator, by the non-tire industry, but they are also used for the butyl tubes cure along with the TMTD, MBT or MBTS. Footwear industry, you mainly use MBTS, MBTS, but also they use F. F is a blend of MBTS and the basic accelerators. It is a blend which was given to the, particularly when there is a microcellular footwear industry was there. So this is a Indian-made product, I will tell you. This is not available out of India. Okay. Then MBTS also used for the hoses, footwear, cycle tubes, etc. ZMBT, zinc salt of mercury, is mainly good for the latex industry. Sensitizer for latex used in the foam, thread, etc. F, I told you, you mainly use for the footwear industry, the blend, but is also used for the sponge, Yogonite compound, hot water bottle, as well as airbags. Then a lot of sulfonamides. I think we discussed about that. CBS is mainly used for the non-tire industry as well as for the small tires, cycle tires, two-wheelers tires, Neolite soling compound if you want a better Scotch safety. What I observed, I don't know, maybe people remember me, in the north side, people were shifting these accelerators. What I observed in the winter, they want fast accelerator because the temperature itself was low. So that time they used to use MBT, MBTS because Scotch safety, whatever you are, they are getting sufficient. But particularly in the summer, when the temperature go up to 50, they were shifting from MBT, MBT to CBS because they want better Scotch safety. Your compound should not Scotch. We should do better Scotch safety, better flow, etc. So you can understand even the same formulation at a different temperature, means I'm talking about the room temperature, that you can change and you can maintain the same cure rate and you can avoid the rejection about your compounds. MDS, I think we discussed about that, particularly earlier used to in truck and bus. It was a very good product, very good SWOT safety, very good cure rate and plateau. But unfortunately, now because of nitrosamine, it is in discontinued. DCBL, I told you, it gives the highest cost safety. So mainly it is used in the steel cord compound and in the unvulcanized products like hot pre-cured trade, conventional system where, that hot pre-cured trade, they have to store for 6 months. So normally TBBS, CBS will scotch, give the scotch. So DCBS is used in they used to call hot trade or camel compound, and Kushabgan compound also normally required very high shelf life. Obviously insoluble sulfur, there you have to use them. Now very important at zinc oxide and fatty acid activation. Here what I have proved that if you don't use proper optimum dosage of zinc oxide and fatty acid, you will not get a proper cure. Graphs are not very clear, but you can see here there are 4 compounds A, B, C, D. A, there are naturable, antioxidant common, carbon black is common, zinc oxide. In first case, the compounder has forgotten zinc oxide and fatty acid. Now you can see there is no curing, it is going flat. Then in second case, he has used zinc oxide, but forgotten fatty acid, that is stearic acid. It is slightly better. It is like this, modulus, it takes more time. In C compound, it has used stearic acid, but it is lower side, not sufficient. So you get like this. In the final compound, which is optimum zinc oxide 5 pHr and fatty acid, stearic acid pHr, you get a proper cure, good Scotch safety, good cure rate, and good modulus. So what you understand, when you are talking about sulfur and accelerator cure, you require the activation with zinc oxide and fatty acid with a proper dosage. So you can see the properties also. Now, A, B, C, D, you have seen A is no zinc oxide stearic acid, B only zinc oxide, C less stearic acid, D is the proper zinc oxide stearic acid. What you observe? You can see Scotch safety is not bad, but T90 is affecting. So when you are talking about no zinc oxide stearic, it is highest T90. As you have started using activator, your curing time is coming down. The major effect is in the modulus. When there is no zinc oxide and stearic acid, even after 25 minutes, your modulus is 4.5. Then when you zinc oxide, 9.5. With a slightly lower stearic acid, 11.9. When you are using an optimum dosage of zinc and stearic acid, in case of sulfur accelerator, you get the optimum modulus as well as tensile. Obviously elongation and hardness. You can see 46 and 62, and in between you get a lower hardness, lower modulus, elongation. So in nutshell, so when you are doing the formulation, proper dosages of activator like zinc oxide and stearic is must. Now, sulfonamide. When we talk about sulfonamide, we always talk about, shelf life, quality of the shelf life. Why? What is sulfonamide? It's an oxidative coupling problem. It is basically manufactured from MBT plus different amine. In case of CBS, is cyclohexylamine. In case of TBBS, tributylamine. So by using different amine and condension product, you can manufacturing a different sulfonamide, right? So basically it is a condensate product. What will happen? Now what happened? So far this product is together, that is MBT and amine, your Scotch safety is intact. Now, Vulcanization reaction does not proceed till all the sulfonyl accelerator quantity has been converted back into MBT and amine. Remember I told you about the synergy? MBT is acidic and amine is a basic. When you use amine and basic, there will be a synergy and you will find a faster cure. That is why in case of sulfonamide, you get a higher Scotch safety because MBT and amine is a condensed product of sulfonamide. And as you go from CBS to TBS to DCBS, your molecular weight is increased, your bigger molecule. So it takes more time to break into MBT and amine. That is why the Scotch safety from CBS to TBS, TBBS to MBS to DCBS or TBSI, your Scotch safety is increasing because it takes more time to break that molecule because of the higher molecular weight of DCBS and TBSI compared to CBS. However, once it is broken, so it is not broken, you have better processing safety with the high dose. As you increase the dosage, your Scotch safety will increase. Once the decomposition is complete, the rate of cure is that of the combination. Your higher the dosage, MBT and amine will be higher, hence the fast rate of vulcanization. That is why the sulfonamide gives better Scotch safety and higher cure rate and the plateau. You can see here MBT, lower Scotch safety, cure rate also is not very optimum, and then MBT modulus also not come that. But in case of CBS, this is one example I've given in sulfonamide. This is applicable to the all sulfonamide. It has a very good soft safety, very fast cure, and then plateau. That is why I said, what is the ideal vulcanization? I think I showed you that time. So sulfonamides, by using sulfonamides, you can give the ideal cure and you can control your cure system. So what is the advantage of sulfonamide accelerators? Longer processing safety, faster cure rate, higher degree of cross-linkage, and very well suited for tire and similar tire type compound like conveyor belt, hoses, pre-cured tread, small car tires, engine mounting, blah, 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 blah. There are many products. Okay. So now, important is these sulfonamides are very important. I think this is not there. Okay. It is there. Afterwards we'll talk. Then we will talk about the shelf life and the consistency of the sulfonamide afterwards. So coming to different accelerators. Now we can see that now we have learned about the thiazole, MBT, MBTS. We learned about CBS, TBS. Now you can see here what is the difference. Now this is the trade compound with natural rubber. Sulfur is around 2.5 and accelerators are 0.5. First column is the Scotch safety at 130. Second column is optimum cure time. And TS is a tensile strength and modulus. Now you can see MBT Scotch time is 35 with 0.5 HR. If you go from MBT to MBTS, your Scotch safety is increasing to 50.5. Same dosage, but you can change it. So now you can, rubber compounder can understand if you want to increase the Scotch safety, what I have to do. Now come to the sulfonamides. CBS, it gives a 56. It is higher than the thiazole. You go to TBBS, it is 64. You go to MBS, it is 70, and DCBS more than 120. So by changing the different accelerators, you can increase the Scotch safety. Optimum cure time is not much affected. Obviously, F is again mixture of accelerators, acidic and basic MBTS, and that is why the cure time is different. But in case of CBS and TBS, you can see 21, 23. Modulus is also almost same. Obviously, DCBS gives the higher optimum time because we have seen in the graph, it is not giving the way CBS and TBS giving the cure rate. So now we can understand this is a glimpsing of different accelerators so that rubber compounder you can understand when they are going back to their office, what type of accelerators, how to improve the Scotch safety, optimum cure, how to reduce optimum cure, tensile, mesh, etc. So this gives the little bit idea. It is not this one. Compound 1. This is again I have given few examples, not going very detailed. What type of options are available to rubber compounder for faster rate of cure? Change from thiazole to sulfonamide. You have seen that. Because in sulfonamide, it is a mercaptan plus amine. You don't require to use booster accelerators. Higher dosage of accelerator. As you increase the accelerator, your Scotch safety will increase, and your cure rate will increase, your T90 will come down. Usage of booster accelerators. You can use thiazole plus basic accelerators. You can use sulfonamide with the basic accelerator like DPG, HMT, etc. Or you can use the booster drug like TMTD, TMTM, or diethylcarbamate. Okay. But now here, when we'll go to that, here the important point is that when you increase the dosage, your cost safety will increase, but your cure time will come down. Someone will ask me, sir, why don't you, I will use retarder. Yes, you can use retarder to increase the cost safety, but your cure rate will not improve. Your cure time will increase. I'll show in the few slides afterwards. So what are the options available to increase the cost safety and decrease the cure time? That will come back. Now, increase of cost safety, I told you. So steel core adhesion, DCBS is a common accelerator used. Why? Because DCBS gives the highest cost safety. When you are doing the adhesion with the steel cord in the conveyor belts, in the tire, in the hoses, a lot of even non-tire industry also use the steel cords or wire also, steel wire also. So you require a good bonding between rubber because it's a composite of rubber compound and the steel. So you require a sufficient cost safety so that the bonding should take place before the vulcanization starts. Otherwise, what happens? Once the compound is cured, no bonding will happen. There will be the failure. So DCBS gives the highest cost safety and it gives the highest bond strength when you are talking about the pull-out strength or the steel cord. Now I was talking about the degradation of sulfonamide. The sulfonamide, though these are good, they are the condensation products of MBT and different amine, but during the high ambient temperature or during the exposure to the high temperature during mixing or during the high humidity also, the sulfonamide get reverts back to MBTS and amine. That is called hydrolysis. So means you require a reasonably fresh sulfonamides. Then quality should be good. What do you mean quality? You should be having, when it converts, degradation what happen? MBTS. And MBTS is reflected in MI, methyl insoluble. Methyl alcohol, you have to do check the insolubility. Higher the MI, obviously MBTS will go over, so your cost safety will get affected. Your T90 will not affected, but cost safety will get affected. So you should have a reasonably fresh product and reasonably stable product. And it also pre-amine. When your product it get decomposed, it will form MBTS and amine. And this pre-amine will act with MBTS and your cost safety will further come down. Obviously, your T90 will come down. So what are the addition only at low temperature and bad temperature? That is why in non-tire industry, the sulfonamides are added on the mixing mill at a temperature around 90 to 100 so that your sulfonamide will not get decomposed on the mixing mill itself. The cost safety will not get affected. In neither sometimes they add it, but at lower temperature. Tire company do the mixing in very internal mixer, but they don't give the temperature more than 100 degrees centigrade. So this is the reason. Storage under cool, dry condition away from direct sunlight, because sunlight will also decompose. Away from hydrolytic influence, acidic rooms. Wet screening of pasture batch or rebuilding pasture batch to be avoided because it decomposes the sulfonamide. The last one, it is a rapid degradation of sulfonamide in dry blends with sulfur. Never mix the sulfur, keep the sulfonamide and the sulfur, it will be there and you will find a fast degradation of the sulfonamide that your sulfonamide cannot be used. So these are the few important precautions I have given you, and I have advised also use reasonably fresh material and consistent quality having a low MI and low free MI. Then these are the few, I will little bit go faster. These are the thiram class, tetramethyl thiram disulfide and tetramethyl benzyl disulfide. What is the difference? So TBZ-TD is made from benzyl, which is not forming nitrosamine. And all thiram, that is TMTD, TMTM, these are made from these secondary amine, methyl, ethyl, etc. So any material, any sulfonamides, any accelerator manufactured based on secondary amine will form a nitrosamine either during the storage or during the mixing or during the vulcanization. So TBZTD being the benzyl group, it is not a secondary amine, that is it not from the nitrosamine. I think this we discuss about the different, you can see here MBT, MBTS, CBS and TMTD were not there. TMTD normally is not used alone. It is used as a secondary, but in some compound they use because sort time is very low and optimum cure time is 5 point when you are using alone. So, but properties and modulus will be same. So you can understand by using different type of accelerator, your Scotch safety vary and your cure time can be vary with the same dosage. So again, I'm little bit, what is the TMTD, TMTM? These are both are thiram class. TMTD, tetramethyl thiram tessine, along with is a booster accelerator. It acts as a sulfur donor, can be used alone. This can be used as a secondary accelerators along with the thiazole as well as the sulfonamide. However, thiram is used as a primary accelerator for butyl and EPDM because they have a less double bond and these are very slow curing rubbers. So you can use as a TMTD. I told you about the butyl tubes are cured with TMTD and MBT. In CR compound, TMTD you as a retarder, not accelerator. This is very important. Many times you'll put retarder, you'll in polychloropine compound, you'll find the compound gets scotched because TMTD is retarder in polychloropine. Rather slow for lattice compound, so it is not used, but in amine-free latex, for amine-free latex, TMTD use in the as a storage stabilizer for natural rubber latex. TMTD is the only booster accelerator. It not act as a sulfur donor. It can be replaced for TMTD. If you compare to Scotch safety, TMTM has a better Scotch safety. Compared to the blooming, compared to TMTD, TMTM has a less blooming. So sometimes to avoid the blooming, you can use TMTM or blend of TMTM and TMTD. It can be used as a primary accelerator for NBR. For mercaptan modified grade CR, you can use it. We will not go. I am showing some few slides for polychloropine extend and EPDM. And TBZTD, I told you tetrabenzyl. It is a nitrosamine free sulfur. Is a sulfur donor as well as booster accelerator. So people want to replace TMTD and TMTM. You can use TBZTD. However, it is not one-to-one replacement. You need some adjustment. You have to use higher dosage because of the molar ratio. Obviously, we'll not go in detail. We can discuss separately. And then thiocarbamate, ZDMC, ZDC, ZDPC. This is methylamine, ethylamine, butylamine. These are all again secondary amines. Only last one, ZBC, zinc dibenzyl benzylamine. So again, I told you we have the TBZTD, again is benzene, and here benzyl. So the last one, ZBEC is the only nitrosamine free thiocarbamate accelerator for EPDM as well as for the latex. So again, I'm not going in details. These thiocarbamates are not normally used in solid rubber compound. It is normally used for notice, for fruit product application, or brightness of color because you can vulcanize at lower temperature. It can use as a booster accelerator for a hot air cure because hot air cure is done at a lower temperature, 100 degree to 120 degree. Primarily, these thiocarbamates are used for the latex compound because you require a faster cure and thinner articles. Retarder, thiazoles and sulfonides are retarder for thiocarbamates. Activer, basic accelerator, guanidine amine can be used. ZBEC is the nitrosamine free accelerators. These are the basic accelerators. DPG guanidine class. There is also DOTG. I have not mentioned, but okay. And amine class, that is butylaldehyde aniline. This is, I think, 576 from Lancet. Okay. Hexa is the HMT. These are the amine class. These are normally used as the booster accelerators in the solid rubber, and butylaldehyde aniline normally used as the secondary accelerator in the rubber thread, that is a lattice application. Guanidine accelerator is primary accelerator in thick walled goods like engine mounting, textile roller, because you require longer cure time, slow curing. But whether it is wise, you can use better normal accelerator with anti-revergent agent and you get a faster cure and uniform curing even in the thick wad articles like engine mounting, rollers, etc., solid rubber, etc. All basic accelerator for sulfur cure of rubber compound containing white practice. White practice are slow, so you require the in case of white practice, DPG is used. Synergy effect with acid accelerators, good accelerator for ebonite compound, DPG is normally used. So now this is just conclusion I have given. So here it is on the y-axis, it is the Scotch time, short to long, and on the x-axis is the relative cure time, fast to slow. Now you can understand. Sulfonamide is on the top right-hand corner, which gives little cure time slightly slower, and but higher the Scotch safety. By adjusting dosage, you can use this. So far, all the articles like tires and the conveyor belts, where you require a good Scotch safety, the sulfonamide use. MBT, MBTS in between, it gives a relatively mid Scotch safety and a cure time. But TMTM, TMDD, ZBAC, these are coming with the lowest Scotch safety and a faster cure. So this gives a nutshell. And DPG also, it is slow curing and medium range of Scotch safety. So it gives a conclusion of different accelerators for Scotch time and the cure time. Now I have just given a few polymers where special systems are required. EPDM is a very critical. EPDM is a non-polar material. Most of the organizations, including accelerators, are polar. Hence, there is solubility factor in the rubber is very important while selecting the accelerators. Blooming on the surface observed if content of accelerator exceeds its solubility limit. Any material which you are adding in the rubber compound beyond their solubility limit, it may go into the rubber compound at high temperature, but after the curing, it will blooms out because the solubility limit has crossed. EPDM has that problem, non-polar and polar, as well as solubility limit will come in the next slide. And it has happened, you have a stearic acid, we have microcrystalline wax, you have a sulfur, you have a TMTD. All these are few names which are likely to be the bloom if you add more than the solubility limit. It is just like, when you add the sugar in the water, at normal temperature, it will make, suppose X. If you heat it, it will again dissolve. But again, when you come room temperature, that is whatever the sugar you are added at high temperature, it will come out. That is called blooming, nothing else. Yeah. Blooming on the surface observed will contain of accelerator exceed its solubility limit. Various factors are also included in the solubility limit, like the filler systems, because fillers are aminic, acidic, plasticizers, other compounding ingredients, oil content, higher the oil, higher the solubility. So it is basically because of the aminic, acidic, and the acidic or alkali nature of fillers and plasticizers. So I'm just going a little fast. So this is the solubility parameters of different accelerators. What you will observe, whatever the fast accelerators, because EPDM is a very slow curing accelerators. So you required blends of different accelerators because of the solubility limit, and you required more accelerators because of for faster curing. Because in EPDM you normally cure in the continuous vulcanization in the profile, etc. So normally thiocarbamates, thionyls are used, but you can see the solubility limit. Sulfonamide and thiozols have a higher solubility limit, but they are very slow curing, so you can't use higher dosage. So there is one product called as ZBEC, thiocarbamates, which has the higher solubility, and there is also a TBZTD and TPS where the solubility limit is higher. We will come to the few others. I'm not going in details. These are, I think, general curie systems for EPDM, standard system with higher processing system, then vast filling system, and system with low cooperation. So depends upon the EPDM applications, you can use this system with the dosage which I recommended, so that you'll get a good optimum cure, good physical property without blooming on the surface. EPDM quantity guideline, again, system with good aging resistance, system with higher elongation, nitrosamine-free systems, and then other is your nitrosamine-free system. Here, I think I have mentioned about ZBC nitrosamine-free, TPS. These are thiophosphate, which have the higher solubility in EPDM, and it is not blooming, and it is very faster cure. So you can use up to 2 to 3 PHR in EPDM. And DTTS, this is a another sulfur donor, thiocaprolactam, but it is not available nowadays. And TPZ-TD, I told you about, you can use. So this maybe I can, if you want somebody, I can share with somebody and we can take that. Again, we'll go for chloroprene. I told you these are normally the metal zinc oxide and magnesium oxide cure system. The standard is 5 PHR and 4 PHR. This is the curve. It is given here. If you use lower dosage, what will happen? You will not get the sufficient modulus. Okay, what are the advantage of zinc oxide and magnesium system? Faster rate of cure, good resistance. When you increase the zinc oxide, even in the normal cure system of general purpose reserve, zinc oxide gives a better conductivity and better heat resistance when you are using higher dosage of 10 to 15 PHR. Good compression set resistance, disadvantage, higher volume swell. If the product it is used in the water swelling or oil swelling, when you use zinc oxide and zinc oxide and magnesium oxide, you will get higher volumes. So what are the system? There are in polychlorine, there are two type of grade. One is sulfur modified and the mercaptan modified. In case of sulfur modified, which is normally used for the good flexing property like V beds, etc. So very fast cure, you have to use ethylene thiourea around 0.02. Obviously, ethylene thiourea is not environmental friendly. There is one product I don't remember. I remember from Lancex which product. Okay, there are substitute has come. For mercaptan modified along with zinc oxide, you can use ethylene thiourea. Accelerator MBTS and TMTDs act as a retarder. MBTS and TMTD act as a retarder in polychloropane, not as accelerators. So for longer process safety along with sulfur, you can use TMTD and TMTDM. For lead oxide cure, particularly for water resistance product, you can use 10 to 24 red lead and TMTM as a retarder with little sulfur. For room temperature cure, you can use diphenyl thiourea along with butylided aniline condensate product, which I told you to for room temperature as well as for the latex. So these are the few application for sulfur and all this. Insoluble sulfur. So I will just touch, I think I have to touch only one slide and insoluble sulfur. What is insoluble sulfur and why it is required? Many times what happen when unvulcanized compound, you want to storage for longer time, either in your factory or unvulcanized compound like hot retate or cushion gum compound where storage typically 3 to 6 months, where normal sulfur will start cross-linking and the Scotch safety will come down and your compound will be useless to use for the retainer. So addition of excess higher dosage of normal sulfur can cause blooming. In order to prevent blooming, a part of ordinary sulfur is replaced by insoluble sulfur. Improve bean storage stability, only compound process at a lower temperature. Insoluble sulfur is basically a polymeric product. So it will remain as a filler when the compound is at less than 90 degrees. However, when it converts into at high temperature, when you are doing curing temperature, this sulfur, insoluble sulfur will get converted to the normal sulfur and it will be available for the cross-linking. Improve bean storage stability, only compound process at lower temperature. Means you have to storage also unvulcanized compound at a lower temperature, not a higher temperature because slowly the cross-link will start even at 50 degree or 60 degree if direct sunlight will come. High temperature processing safety, same with soluble or insoluble sulfur. If you are doing mixing at high temperature of 110 and all this, whether you use insoluble or sulfur or soluble sulfur, it will not make. So you have to do the mixing at lower temperature. Rapid conversion of insoluble to soluble sulfur in presence of alkaline aminic material. So that is why your aminic material should keep away from insoluble. Even sulfonamide, DPG, hexa, all should keep away from insoluble sulfur to avoid the conversion of insoluble to the soluble sulfur. It should be kept in the proper original packing, properly stored, no direct sunlight, no aminic material should come into contact with the insoluble sulfur to avoid the conversion of insoluble to the soluble sulfur. To avoid dust explosion, it is oil coated up to 20%. Sometimes polymer bound also is available. There is a sulfur donor also we have heard about. Again, why sulfur donor? This organic compound can sulfur in a thermally labile separate change form. Under normal curing condition, free sulfur will release. So a sulfur donor will not react at a normal temperature. It will remain as a filler. Under normal curing condition, free sulfur will be released, which in contrast to normal sulfur, it will give only mono and disulfide. That is why many times normal accelerator, sulfonium accelerator will be replaced by sulfur donor in order to get a mono disulfide bridges and higher cost safety. Because of their higher bond energy, these disulfide bridges are much more resistant to reversion and responsible for the excellent heat resistance of the vulcanized. Replacing sulfur with sulfur result in less free sulfur in the rubber and leads to advantage as improved physical property, lower compression set, excellent reversion resistance, vulcanized with improved aging resistance, no sulfur blooming, provided it not get exposed at higher temperature. No contact staining with heavy metal because there is no heavy metal like lead, etc., which is there in the sulfur. Higher processing safety. I will also give, it gives a better color also because sometimes sulfur gives the darker color, normal sulfur. Lead, whether it is red or white also. Now we talk about peroxide also. I will not go in detail, but what is the difference between sulfur and peroxide? Sulfur, only unsaturated rubber. Also saturated polymers, peroxide. You can do unsaturated also, saturated if you require any special properties like compression set, etc. Sulfur gives good tensile, tear, good flex property. Peroxide gives excellent stability, excellent compression set. Sulfur gives a reversion in case of natural rubber and polyisoprene. Peroxide, no reversion. Red depends on the polymer. Red depends on the peroxide, type of peroxide, quantity of peroxide. And also activator. There is a peroxide activator also used to reduce the peroxide consumption. Many compound ingredients in sulfur. You require zinc oxide, stearic acid, 2,3 accelerators, sulfur, blah, 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 retarder, etc. In peroxide, it's a simple compounding, no intermediate ingredient, maybe only peroxide plus activator. Hot air cure possible in case of sulfur. In case of peroxide, tachysurface. Why? Because in hot air cure, air get reacted peroxide, and the peroxide will be not available to the cross-linking. So peroxide will get consumed by air reaction. So the surface will be tachysurface. Often blooming in case of staining, that we have seen that in case of sulfur, if you are using normal sulfur, it will blooms out in unvulcanized compound. Clean vulcanized, scorch-free compound, scorchy compound, but good scorch retarder possible, or different accelerators are available. You add retarder, you can control the scorchy. But in case of peroxide, good shelf life limited to scorch retardation. No possibility to use any retarder along with peroxide. Sulfur is economical, peroxide is expensive. There is another last one, resin cure. Vulcanization with dimethanol phenol resin derived from condensation product of formaldehyde with 4 alkyl phenols. So what is this resin cure? This rate of cure improved through this is a resin cure used for butyl or halobutyl. However, when you are using this resin, you have to use rate of cure can be improved by catalyzing action of metallic halides, stannous chloride, or halogen containing polymer like polychloropene, CSM or CIR, or even chlorinated waxes. Use of brominated resin does not require halogen because bromine is already there in the phenol. So if you are using normal resin, you require activators. When you are using brominated resin, you don't require activators. Where this resin is used? Wherever you require the cross-linking and the product which high heat resistance. Now you are, how about the bladders? Bladders are used for the tire curing. So in bladders, from the inside, they use hot air, they use steam, etc. So and temperature go up to 180. So normal rubber will not withstand. Normal curing set will not withstand. And these bladders or airbags are used repeatedly, maybe 200 times, 400 times. So, and they will put cold water, they will put hot water, they will put steam, etc. So they have to withstand. So that is why the resin cures are used for the butyl bladders, airbags, envelopes are used by the pre-cure traders, or there is another application called as EPDM polypropylene blends. Okay. Because EPDM is the rubber and polypropylene is the plastic. So in order to blend that, the resin cures are used, and these EPDM polypropylene blends are used for the car parts like bumper, etc., which gives a little bit elastic properties to the plastic. Retarders, I will not go in details. Retarders used where the danger of scorching of pre-vulcanization is there. So there are a lot of retarders, but normally now all people are using cyclohexyl thiopuramides, that is PVI, effective at lower dosage, even in presence of PPD antioxidant, no porosity, no effect on rate of cure. Now just you can understand, as you increase the dosage, this is a graph or curing time versus the modulus, Scotch safety. As you increase the dosage from 0 to 0.75, your Scotch safety is proportionately increasing. Here you can see. However, you have to understand, when the Scotch safety is increasing, proportionately your cure time will also increase. Then what are the options? Instead of you use sulfonamide wherever possible, or changing from CBS to TBBS to MBS, your Scotch stability will increase. However, your cure time will come down. So this is the difference between the retarder and the sulfonamide. So you can judge, depends upon your requirement, depends upon the configuration of the product. Last, I'll touch nitrosamine. What are the nitrosamine? Last, I think 30 for 50 years, I have seen this topic has come. The rubber chemicals, mainly accelerators, made from one of the raw material that is secondary amine. We have heard about methylamine, ethylamine, morpholine. These are the secondary amine. We heard about the CHA, which is not secondary amine. This is a primary amine, tertiary amine. So only secondary amine. We have heard about the ZBAC. We have heard about the, ZDEC, ZDBC. These are made from the secondary amine. So these secondary amine, which react with nitrous oxide and form a nitrosamine, where it forms present in fillers. Amines, these are present in fillers, formed during the curing time, and form amine residue also. So these amines, free amine coming from the accelerators, or during the vulcanization where it is brushed, the amine comes out, it react with the nitrous oxide and it form a secondary nitrosamine. And these nitrosamines are carcinogenic, cancer oriented. So nitrosamine are formed within the rubber matrix in the air from amine release during the vulcanization or after vulcanization. And this yield amount of nitrosamine depend on yield of nitrogen reaction, volatility of amine, volatility of nitrosamine, accelerator system. If you have conventional, you have a less accelerator. You have an EV system, you have more accelerator. So more nitrosamine will. And polymer film also because of the amine systems. So this is last slide, which is a conclusion of nitrosamine. I have given present accelerator being used in India, accelerator having nitrosamine issue and safe accelerator. If you take a sulfonamide, MBS, CBS, TBBS are used. Out of that, MBS is having a problem because it's made from the secondary. What are the safe? CBS and TBS are safe. Sulfonamide, DCBS and TBSI, no problem. Both can be used as safe accelerator. But I have given slightly color to DCBS because in some country like Japan and all these, they are discussing that DCBS is in the borderline. Even for the OE manufacturer, when you are supplying the tire, you have to disclose the quantity of DCBS. There is a restriction to use DCBS in Japan because of this border issue. So TBSI is a more self-accelerator, giving a similar properties, cost safety, and it helps in the better bonding with the steel cord. Then sulfur donor, TTDM and TMTD, both are in the blacklisted. Nitrosamine issue, TBZTD is good. There is one that I told you that sulfur donor, that is dithiocapryolactam, which is normally not available nowadays, but I don't know. But that is also a nitrosamine. Secondary accelerator, TMTD, TMTM, DPG, TMTD and TMTM both are in the red. DPG and TBZTD and TPS are safe. TPG should also give slightly color. We should give a yellow color because it also a question mark. It is not yet been banned yet, but future there is a possibility. Okay. So thiocarbamate, ZDC, ZDP, ZDBC, all in the red. ZBEC, zinc dibenzyl is the only safe accelerator for latex, also ZDBEC. So when you have a problem for secondary accelerator, nitrosamine phi, you have only 2-3 options. TBZ, TD, TPS and ZBEC can use as a secondary accelerators or latex primary accelerators for nitrosamine free system, particularly when you're exporting or your customer demand. And with that, thank you very much for listening patiently. Hope I justify your time you're given in the evening. And I know this was a little bit faster, but unfortunately to cover all the topic for vulcanization cure time, I tried my level best. Thank you very much. Thank you to Mehul Bhai to initiate this process. And this is a beginning. Maybe this will continue to do that. I told you, I have not touched one vulcanizing system that is called anti-reversion, because when you are doing the polysulfide system, in some application, you require a good, better tensile, better tears property, and bare flexibility. So then what is the advantage? So you have a polysulfide system, but you want long chain systems, but you don't want reversion. So anti-reversion is the only option. Maybe next time we can take 1.5 hours lectures on anti-reversion, which is a new technology product. And for product like natural rubber, where the reversion is unavoidable and where a lot of heat generation is there, anaerobic region is there. So we will discuss later. Thank you very much.
Thank you very much, Mr. Katkar. It was an excellent presentation. You must have spent a hell of a lot of time preparing all these slides and, working on it. So thanks for all your efforts and time. And I think there has been a lot of appreciation from all the people around on the screen. Also, you can see people are appreciating your presentations. Before we close, there are a few questions I would like to take up if you don't mind. So
Yeah.
I will read out some questions from the chat box. There are about 8-10 questions there. If you can kindly answer those, it will be nice. Yeah.
We'll try.
So let me start with that. First is for food grade EPDM products, which are the accelerators that can be used?
Yeah. So food grade, I told you the most advantages are the thiocarbamate. Because all the accelerators like thiozols, you cannot with sulfonamide, these are based on mercaptan. So food grades are not all. So you have the option of thiophosphate and the ZDC, ZDBC, ZBC, that whole family.
Carbamates, yeah, correct. Sure. Okay. Next question is, hello sir, kindly suggest cure system for 80-20 NRSBR based rubber strap compound having no frosting or blooming issue.
So you talk about general. So frosting means why? What is the application means? What is the temperature?
The strap compound, Hawaii strap compound.
Hawaii strap compound. Okay. Normally, we normally suggest F along with sulfur conventional system, but the best I will suggest as a CVS with sulfur system. No blooming and better cost safety and faster cure.
Yeah, I think most of the time now, today's time, straps are injection molded also. So, you can suggest based on that probably.
Yeah, because you require a longer cost safety. Because as you rightly said, many times they do by injection molding also. So you require a good cost safety. The CBS sulfur is the best option.
But okay. I don't know why SBR should be used in strap,
The reason I told you now, because if you are talking about high temperature cure injection, SBR gives slightly reversion resistance because natural rubber is reverting and SBR gives the marching model.
Correct. True.
Otherwise, normally strap is only natural rubber because it gives better tears properties.
But nowadays they use NBR PVC also, Mehul Bhai, right?
Yes, that's correct.
Because NBR PVC is a better life and all this. It gives rubbery because nowadays people don't use natural rubber in the footwear. They use mostly
Correct.
EVA and all these.
I know. Yeah, next question is, sir, good to know about accelerator switching due to weather change in north region. Thanks. That's the, suggestion which you had given, no?
But this
Switching
is
this
applicable.
thing.
No, I have given example for not. This can be applicable for any region. I mean, any country, any region where the drastic change in the ambient temperature.
Correct, yes. In fact, this reminds me, if I may take a half a minute while
Yeah, sure,
going through
sure.
this, my daddy, Mr. Manu Patel, used to tell me that once he was in Punjab area and somebody at 9 o'clock in the morning was throwing some MBTS on the ground and he was doing some quality control for finding out whether it is MBTS or not, because he told that if the ants comes, then it is the gram flour which are, supplied by the customer, by the supplier, and not the MBTS. So this is the way people follow also actually. Okay. Why are zinc oxide and stearic acid specified for sulfur accelerator cure system? Will zinc stearate do the job as well? So
It
instead of
forms the
zinc oxide and stearic acid, can you use zinc stearate straight away? That's the question.
yes. If you do adjusted dosage of zinc and stearic, but you have to see that I told you zinc oxide and stearic is optimum dosage are there. Zinc stearate combination you have to see. Otherwise, you can use zinc stearate plus whatever the deficiency is there. You can add the more stearic acid or zinc oxide. Yes, you can do that.
What is the percentage difference of bond strength when that cured with DCBS against CBS and MBS? Bond strength, change of bond strength, yeah.
I have a lecture of one and a half hour on bonding. Maybe next time I'll just tell you, it is not the bonding. I'll tell you, in case of steel cord, I told you that the cost safety is very important. So DCBS gives the highest cost safety compared to CBS. Suppose tomorrow you use CBS, and before the bonding, your slightly cross-link started. So obviously your strength will be less compared to, with CBS it will be less compared to DCBS. So there is a percentage wise there, but depends upon again, how much temperature, what you are giving, DCBS, how much you are using, all these are there. But there is a drastic higher steel cord bonding strength with DCBS compared to CBS or thiazole.
Okay,
So,
I think in addition to that, there is a question that does DCBS give better adhesion with RFL dip with nylon fabric compared to all other sulfonamides? So when you have a RFL dip fabric, does DCBS give you better bond strength? That's the question.
No, normally RFL deep they don't use DCBS much there because that is a separate bond. Steel cord adhesion is different and the RFL deep, because RFL already in the latex stage only they use resorcinol, formaldehyde, etc. Okay, so DCBS there we don't recommend because again it will be interfere with your other compounds and all this. So where they can use normal KBPS or CBS also. But DCBS will definitely, if you use it, you will get higher cost safety, bond strength will be higher definitely.
Okay, next question is that TBZ-TD is forming a secondary amine. However, the product is considered as safe. Why is that?
No, wrong. TBZ-TD is manufactured not from the secondary amine. It is tertiary butyl benzyl. Benzyl amine, whether it is the ZBAC or TBZ-TD, it is not secondary amine, so it is not forming the nitrosamine. Okay, I think you're wrongly read. I have never written also, I have never spoken also. TBZ is a safe ultra accelerator as a secondary accelerator when you add with thiazole or sulfonamide instead of TMTD, TM.
So you are trying to say, the gentleman is saying that TBZ-TD is forming a secondary amine during...
No.
So it doesn't. That's what you are trying to say. Okay,
yeah,
fine.
TBZ-TD is made not from secondary amine, so it is not forming the nitrosamine. So it is safe.
Okay. Dear sir, how to design non-sulfur EPDM compound for EPDM polymer?
Non-sulfur, what do you mean that?
That means peroxide, I think, right? Non-sulfur also.
That is a peroxide.
Yeah, then it becomes a peroxide cure. There is nothing else available. No resin cure or nothing of that sort.
EPDM there is no available, only peroxide, yes.
Correct. What are the nitrosamine-free accelerators available in the market for chloroprene and EPDM rubber? I think you already answered these questions.
Yeah.
You've been talking about this again and again.
That last slide is very, that is give the gist of nitrosamine issue. Last slide. Okay. Yeah.
Correct, correct. Why peroxide cure, EPDM, and sulfur cure are not equally preferred in EVs? Mostly sulfur-free EPDM rubber is preferred in EVs, electric vehicles. Is the question?
frankly-
Did you get the question?
No, I heard that. He said
Yeah.
in EV vehicle, EPDM with peroxide they use. Frankly speaking,
He says that it's other way. Mostly sulfur-free EPDM rubber is preferred in EVs. That means peroxide. Yeah, you are right.
that is
Correct,
peroxide. No, that is I said peroxide.
Correct.
Frankly speaking, on EV, I have not done much work because there is no information available also. What possibility? I don't know exactly.
That
So
would be a
only
reaction of sulfur with some metal or something.
Yeah,
Something
that's
like
why
that.
I've said what type of which product you are talking about for EV?
I don't know. That will
that
not
we-
be answered straight away. Yeah.
Yeah, because that
I
is
think
very
we can
important.
go
Then I
ahead.
can answer better which product you are talking, whether you are talking about
Sure.
EPDM profile.
So you can, the gentleman can ask this question on the group tomorrow. Yeah.
Yeah, afterwards.
No problem. Can one safely go for polymer bound accelerators completely in NBR and NBR PVC? That means, can you use sulfur bound accelerators?
No, not sulfur bound, polymer bound.
Polymer bond, not polymer bound
you can-
accelerators in NBR or NBR PVC. That's the question.
No, you can use polymer bond in any polymer. If you are using, suppose, X accelerator, in polymer bond, you require higher dosages and you have to pay a higher price. So your product is affordable. Your final price of your product, it is affordable to polymer. You can use it. Otherwise, no. So the function will be same, but you have to use higher because polymer bound either they are 70% or 75% or 80%. So you have to adjust the dosage. That is one part. But obviously, polymer bound will give a good dispersion. There is no issue. That's all.
Sure. Next question is, I think, already asked. Instead of using stearic acid and zinc oxide, can we use zinc stearate?
Yeah,
that has been already answered actually. So let's skip that. Can one have 5-minute curing time in peroxide cured HNBR? Part thickness is not much. Metal bonded seals. That's what the question is.
Yeah. Basically, in peroxide, what I told you, you have only choice of either what type of peroxide, because different peroxide available for different temperature, benzoyl, chloride, etc. So you have to select the peroxide first, whether what temperature you are talking about. Okay. Second, activator also is there to activate the peroxide curing, and then dosage. That's all. So you can adjust it. Then you have to add more peroxide and combination of selection of peroxide and peroxide, because peroxide has to decompose that temperature. No? Temperature about the decomposition peroxide is very important. So choose the peroxide proper, use activator accordingly, and use higher dosage. You can cure at 5 minutes if it is viable for your molding. Okay, am I right, Mehul?
Okay, yeah, correct. Now there are more than a dozen appreciative, for your presentation messages. So I'm not going to get into those.
No,
details.
don't. Only utilize
Now,
the timing for the better way.
any guidance to prevent bladder degradation?
Yeah, bladder degradation is first. I think you understand you have to use resin cure. Am I right? So
Correct.
you have to use good consistent quality, because resin methanol content is very important. Because as you store the resin, sometimes hardening happen, right? So now that is one. So you use methanol resin, which is fresh and good storage stability and consistent methanol content. Because bladder curing will depends upon the methanol content of the resin. That is one. But I have done some work that by using some anti-reversion agent, you can increase the bladder life. Bladder is also, really design part is very important. Formulation is better. Mixing is very important. Resin quality is also important. Dispersion is also important. In addition to that, I told you some anti-reversion, but it is not been commercialized, but we have done some work that they also improve the life, because it is a flex property. If you improve the flex property of the resin cure bladder, then your life will increase.
Job is done. Yeah, correct. Next question is, which accelerator is more preferred for rice husk polymer? Not polymer, polisher. I'm sorry. Rice husk polisher.
Yeah.
Whether it is METS or F.
Rice polisher is basically naturable, 100% naturable. Naturable
Correct.
plus polybutadiene. So it is not very thick particles. So you can use MBTS or CBS. There's no problem.
He's saying METS or F. So you are preferring METS instead of F.
Yeah, yeah. F also is
Okay.
MBTS plus basic accelerator, but okay, whatever. Yeah.
Okay. Is TMTD banned already?
I think EMTD, you will not believe, just for the information, in 90s, my earlier company, I went to Germany. So in 1990, this discussion was there. But in
Correct.
India, after 35 years, still
Still
people
being
are using.
used.
But as a supplier, we have given you option available. I have discussed also TBZ, TD, etc. It is available. So
Ah,
depends upon your customer is not accepted. He is insisting you have to give declaration. If you are exporting, there is no action. You have to stop TMTD immediately and use option available. There is also thiophosphate TPS also can be used. Depends upon the product what you are talking about. Okay.
Okay, I think there are few questions, but I will. We are running out of time now, so I will ask only one last question. In EPDM peroxide curing at the time of checking show a hardness. Why hardness shows 2 to 3 degree revert? You see the reversion or the lowering of the hardness while measuring DCP 4 pHR, TAC 2 pHR, and sulfur 0.7
Yeah.
pHR curing
Yeah.
system.
Yeah. I don't know. For peroxide cure, you require a post curing.
Hmm.
If you don't post cure, then this problem will be there. So post curing is must for any peroxide cure to optimize and the stable properties. So maybe I think you are missing that or may not be sufficient. And that temperature timing is must. Am I right,
Yeah,
Rahul?
somewhere down the road, he has said that 175 degrees centigrade 10 minutes for 12 thick button.
No, I said whether you are doing the post curing or not.
No,
That
he's
is,
not mentioned post curing at all,
but
actually.
post curing is must and sufficient time for post curing so that your properties are consistent. That type of post curing timing has to be given.
Correct. Okay, last question. What is a single pack accelerator?
Single pack. You have seen EPDM. I have not gone to detail. EPDM is basically a slow curing because double bond is in the only side, only to hardly 2 to 5% of double bond. So when the double bond is less, means you required more accelerators and more fast accelerator required. So you have seen that number of accelerators you have to use, and there is also issue because of non-polar and polar. Blooming. Because of that, there is a blooming, and blooming is directly proportional to the solubility limit. So you can't use any one accelerator higher. Suppose tomorrow one accelerator you want to use, blooming will be there. So you have to use number of accelerators. So many times for small customers, which type of accelerator weighing, accurate weighing is required, and which I should add, and there is a wrong weighing, and then there is a problem in the blooming. So what we have done as a general for small customers for EPDM general formulation, we have blend 2-3 accelerators ready made. By using this, you don't require to wait, you don't require to carry the inventory, there is no mismatch, and you are safe for your query. Am I answer? I think Mehul, you can add
Correct.
also.
I think, yeah, you are correct, actually. Instead of weighing 3-4 chemicals, inventing 3-4 chemicals and maintaining different chemicals, you can have one pack system which will help you definitely. Yeah, I think with this we come to the close of this presentation. Once again, Mr. Katkar, thank you very much. Thanks a lot. We had a talk about this about 3 weeks back, and immediately we decided that we should have such present because small scale industry definitely requires such input. I would also like to, whenever possible, we request you sometime down the road
Okay.
on the group if you can share some more details about the FDA,
Yeah, yeah, okay.
accelerators which are suitable for FDA, because that's more common questions which are asked,
Yeah,
particularly to me when I'm moving around the industry. People ask me about the suggested accelerators for the
yeah, yeah,
FDA applications.
yeah,
So
yeah.
if you can kindly share some details further on the
But
group, it will be nice.
normally supplier should be able to give that information when you ask. But okay, if we can discuss. Only one line I
Yes.
want to add, and I will request afterwards also my colleague Ganesh is also there. He can also put one line afterwards. My is that first I am telling you that I am a student of IRI. Okay, after working with this industry for 40 years, time has come to give it back. So whatever I have done, I have not done anything great. This is what is my responsibility and to give it back to the rubber industry. And Mehul, as I said, whenever you are calling, I've done in my Mumbai, IRI Mumbai, whenever my help is required, not only India, not only Mumbai, but anyone asks my help, whatever I best can, I can share my knowledge, my experience with the rubber industry. I'm always there. And this is my responsibility.
Yes, it is a foregone conclusion for you actually. So don't worry about it. Everybody knows about it. Yeah.
Achha, Ganesh,
Thank
want to
you.
add anything? Ganesh?
Nothing
Yes,
else.
yes,
And
absolutely.
Because Ganesh is now, all India.
correct.
Ganesh?
Yes, absolutely. What we can do is Megulbhai can take an initiative. I remember we used to get 500, 600 people. Do you remember?
That's true. Correct. During COVID time, because probably
Yeah.
people were more free at that time. Right now,
correct.
probably people are not as available as it used to be during this thing. Anyway, I'm trying my best to go to such numbers, and we will certainly over the period of time we will
Anyway.
go to such numbers. Yeah.
Excellent. This one, Megulbhai.
Yes. Thank you very much, and thanks everybody. I think even the members have maintained the pin drop silence during the presentation. So that's very, very kind of them and very nice of them. Thank you. Okay. Good night, everybody. Thank you, and we see you again in 2-3 weeks time. Again, I have one very interesting topic coming up
good night.
in next 2 or 3 weeks time. So I will keep you posted on the new topic, next topic. Yeah. Thank you very much.
All the best.